Hello friends, hope you all saw the previous video of forces. In this video, we'll be seeing the types of forces. We'll also be discussing about contact and non-contact forces. So let's begin. Contact forces. Contact force is a force that is applied by objects in contact with each other. The contact force acts on a point of direct contact between the two objects. So contact forces are those forces which only occur or which only apply when they are in contact physically in touch with each other. Let's see all the kinds of contact forces. Frictional force. Many of you have heard frictional force. So it is the resistance to motion of an object. It is not a fundamental force like gravity or electromagnetism, but scientists believe that friction is caused because of the electromagnetic force of attraction between charged particles in two touching surfaces. Friction always works in the direction which is opposite to the motion of the object. This is because in whichever direction an object is moving, friction tries to bring that object to rest. Friction is more on a rough surface than a smooth surface. The magnitude of frictional force is also higher when we exert a greater force on an object. Hence, the rougher the force, the more the friction, and a greater force we apply on the object, the greater the friction. Here's an image of frictional force. See, a man is pushing a block, but the frictional force is opposite to the direction of the man's muscular force, the push of the man. Hence, we can conclude that frictional force is an opposite force to the motion of an object. Is a frictional surface possible? We'll be answering this question on our upcoming video of Newton's first law of motion. Normal force. This is the second force we are going to see. Normal force. Normal force is a support force exerted upon an object that is in contact with another stable object. It is perpendicular to the surface of the object that it contacts. If an object is at rest, the net force acting on the object is zero. This is because weight, a non-contact force, is equal to the normal force. Will not be seeing much about normal force now, but we'll be learning it soon. Here's an image of normal force. As we can see here, it is perpendicular to the surface, perpendicular, and it is still, it is not even moving, so the net force is zero. Tension force. The tension force is defined as the force that is transmitted through a rope, a string, or a wire when pulled by forces acting from opposite sides. Tension force is directed over the length of the wire and pulls energy equally on the bodies at the ends. Tension force is only a pull force, it is not a pushing force. And we'll also be learning about tension force soon. Here's an image of tension force. As we can see here, there's a string which is pulling this block, and hence it is a push force. And sorry, hence it is a pull force. Applied force. The applied force is a force which is applied to an object by another object. It is similar to that of impact force, but impact forces uses the concept of impulse, which we'll be seeing through before we complete force and laws of motion. Applied force is a constant force, unlike the impact force. Here's an image of applied force. The man using his muscular power is pulling the lever down, hence applying a force on the lever. Next, we'll be seeing about air resistance. Air resistance describes the force that are opposite to the relative motion of an object moving in the air. They are also known as drag force, which acts opposite to the oncoming flow velocity. Thus, it slows down the velocity of the object. Here is an image of air resistance. As we can see, parachuting is a really good of usage of application of air resistance. The main reason why we use a parachute is to lower the velocity so that we won't crash on the ground. So when the surface area of the parachute is more, the air resistance is more because the air molecules will be hitting more amount of the parachute, and hence will be falling smoothly on the ground. Other contact forces include buoyant force. Buoyancy or upthrust is an upward force exerted by a fluid that opposes the weight of a partially or fully immersed object. We'll be seeing about more about buoyant force when we learn about fluid mechanics. Next is the spring force. Spring force can be easily described as the force exerted by a spring. Next is thrust. Thrust is actually a reaction force described in Newton's third law of motion. It is also a perpendicular force acting on a body. Now let's start discussing about the non-contact forces. A non-contact force is a force which acts on an object without physically in contact with the object. Now contact forces are forces which only act when the objects are touching, but non-contact forces act when the objects are not touching. Now, first example is gravitational force or gravity or weight. Gravitational force is the force which acts between any two objects in the universe. It is a non contact force because the force exerted to two bodies which are not in contact, two or more bodies which are not in contact. Gravity is generally the force in which Earth pulls other objects and is also used for describing the force of other planets pulling objects down. Weight is the mass of the object times gravity. W is equal to mg. You might have heard in the gravitation chapter many times. Then next is the electrostatic force. The electrostatic force is also known as Coulomb force, which is the force between two charged objects. It can be attractive or repulsive. Like charges repel and opposite charges attract. Electrostatic force only exerts a force when the objects are sufficiently close together, unlike gravitational force. Next is the magnetic force. Magnetic force, attraction or repulsion that arises between electrically charged particles because of their motion. It is responsible for such effects such as an action of electric motors and the attraction of magnets for iron. Example of magnetic force. Now, here are images of gravitational force, electrostatic force, and magnetic force. This is gravitational force. The Earth is pulling the apple down. This is how the great Isaac Newton found the concept of gravitational force. And here's an image of like charges repel and unlike charges attract. So positive and negative they attract, and positive and negative they repel. And here's a image of magnetic field, north and south pole, and hence we have completed thoroughly the concepts of contact and non-contact forces. Thank you so much for watching this video. Do not forget to subscribe our channel. We will be uploading beneficial videos like this and we have a lot more for you. Thank you.